You must have heard about vector database where you can store your embeddings. Pinecone is also one of them. You can create your free account and create vectors and store them in Pinecone. Let's go to Google and in Google type Pinecone. You can click on this website www.pinecone.io, and when you come on this page, it says that build knowledgeable AI. Pinecone serverless lets you deliver remarkable GenAI applications faster at up to 50x lower cost. You can click on this product, and here you will see the most popular vector database now serverless. And if you scroll down, you will get a lot of information about this Pinecone. So it says that any AI model, it is compatible with embeddings from any AI model or LLM, including those from OpenAI, Anthropic, Cohere, Hugging Face, Palm, etc. And we will be using Hugging Face to store our embeddings. And about the integrations, it says that supercharge your AI stack with integrations for popular data sources, frameworks, models, and more. You can get more information about this Pinecone vector database on this website. Now you have to click on this sign up if you are a first time user, and then you have to just select your Gmail account to log in, and that's it. And if you already have an account, you can just click on this login. Because I already have an account, I'll click on this login here. Now you will see a UI like this. So this is an index. If you see here indexes, you see one index because I created this index. In your case, if you have just signed up, you won't see. And I can also delete this index. Let me delete. So I'll just paste this here to delete it, and then this will delete. So now if I refresh this page, even I won't see any indexes here. Then we have collections, and here you will get your API keys, which is a must to use, because whenever you want to store your index, you will need an API key from Pinecone as well. And this is my API key that I'm going to show you now how I will be using it to connect to this Pinecone vector database. Now let's go to our Jupyter notebook and let's start how we are going to create embeddings. We will store them in Pinecone vector database, and then we will also query our document that we are going to load in this tutorial. So let's go and see them step by step. First, I'm going to import OS, and then from get pass, import get pass. Now I'm going to create this Hugging Face token and store it in a variable hf underscore token, and then I will call this get pass. I'll go to this Hugging Face and copy this token from here. So please make sure that you do not share your access token with anyone. Here you can see my access token, but after this tutorial I'm going to revoke this and create a new one. Now I'll execute this code and I will put this API key here. Then the second one is we have to create a Pinecone API key environment variable as well. So I will write here Pinecone underscore API underscore key, and then again get pass to store this. Now I'll go here in Pinecone, I'll just click on this and I'll come here. Let us execute our code. Now I will put the Pinecone API key. So I have set the API keys for both Hugging Face and Pinecone. Now with the help of Hugging Face, later we can query our data. I will create one LLM model first. So I will make an object LLM, and before that I need to import Hugging Face inference API. So I will write here from LlamaIndex dot LLMs dot Hugging Face import Hugging Face inference API. and it is not giving me, so I will type here Hugging Face Inference API. Now I will call this Hugging Face Inference API here. Inside this, my first parameter name is model underscore name, and I will just write it here, and then I'm going to use Mistral model. So I'll just go to this Hugging Face here and search for this model Mistral AI, and then I will use this one Mistral's 7 billion parameters. I'll copy it from here and then I'll paste it here, and next I have to pass this token parameter, and in token I will pass this HF token. So I have just copied from here and I'll paste it here. Now let me print this LLM object. So I have created this LLM. This I'm going to use later to query our data. Now next step is to load our data, and in this case I'm going to load one text file. You can load any file, CSV, JSON or any other. For that I will be using simple directory reader. So first I will import it from LlamaIndex.core import simple directory reader, and now I'm going to make an object documents. Then I will call this simple directory reader. Inside this, my first parameter is input underscore files, and inside this I will give my file name, which is Paul underscore SA underscore text, and then I will close this, and to load it I will call the method load underscore data, and then I can even look at the document. So I will write here documents, and I will look at this index 0 dot get underscore content, and let us execute our code. Now you will see the document that we have loaded here. So here in the output you can see that this is the document and it has information. This is an essay from Paul Graham. So this is an entire essay. We are going to create an embedding of this essay and then store this in Pinecone vector database. Now let's import Hugging Face embeddings, because we will be using Hugging Face embeddings to create embedding of this document that we have just uploaded here. Now let's import from LlamaIndex.embeddings.Hugging Face import Hugging Face embeddings. You can use any embedding here. I am using Hugging Face embedding because it is free, and then I'm going to create an object of this embed underscore model, and then I will call this Hugging Face embedding class. So I have this embeddings in this object embed underscore model. Now we will go to the next step where we will set up a connection to Pinecone and create a new Pinecone index with the specified parameters, and this index will be used to store vector embeddings for later retrieval and search. So first import the libraries that we need from pinecone.grpc. Import Pinecone grpc. I'll explain you everything step by step. Then from Pinecone dot, or just import serverless spec. We have already read in the documentation that it is serverless. And then from LlamaIndex dot vector store dot Pinecone import Pinecone vector store. So we have imported this and I'll execute this code. And before that, I'll show you that in indexes, we don't have any index. We will be creating a new index. We will initialize connection to Pinecone, and this can be done using Pinecone gRPC. I will make one object PC which refers to Pinecone, and then I will call this Pinecone gRPC. This will help us to interact with Pinecone vector database. Inside this, I will pass one parameter. The parameter is API underscore key, and here we will pass our Pinecone API key that we had here created. So I'll pass this. I'll write here Pinecone API key. Now this will create connection. Then we will give our index a name. I will write here index underscore name an object, and the index name will be llama integration example. So you can give any name here to this index, and then I will execute the code. So this will define the name of the Pinecone index to be used. And now we'll go to the next step where we will create index, and for that we will define some parameters. So first one is, let's call this PC or this Pinecone connection that we have created here, and then let's create index. So I will call the method create index, and inside this the first parameter is index name. What would be the index name? And we have already created this index name, so I will just pass this as our first parameter. So we have defined the index name. Second is dimension. Now it specifies the dimensionality of the vectors to be stored in the index. Now how you would come to know what would be the dimensions here? So here we are using Hugging Face embeddings, and the Hugging Face embedding model that we are using is, I'll show you here, it is BAA, yes, this one, BAI BGM3, and I'll click on this. Then I'll scroll down. Now if you see here, you get the information about the embedding models and their dimension. In our case, we are using this BAI BG small English version 1.5, and its dimension is 384. So that is why here we will give the dimension as 384. Now if you are using any other embedding model, please make sure that you get the information about the dimension and pass it here. If you pass the same dimension to any other embedding models like OpenAI, then you will definitely get an error. So you must know the dimension of the embedding model that you are using. And then the last parameter is spec, or that specification. We will call this serverless that we imported. So we'll spec, and inside this, whatever index we are creating, this is going to be stored in AWS cloud on this Pinecone website. So right now we don't have any index here. If you see here, we are not having any index, but when we create, this will store in this AWS cloud. And once it is created, I will show you all the information in the Pinecone website. So now our first parameter inside this is cloud, and Pinecone uses AWS. And then the next parameter is region. So we have our free account here, and for free account, the region that works is US East 1. So if anyone who's watching this tutorial and is not aware of AWS, so please don't worry about this. You can simply write here cloud is AWS, region is US East 1, and those who have some information, they might know what region means. So if you have no information, nothing to worry about, just pass region as US East 1. Now let us execute our code. So it says that incomplete input, and here I am getting some incomplete input here. So okay, Okay, so I have to pass, or okay, I have to close this, and then I have to close this final one. Now I should not get an error. Now it has started creating an index. Let's wait. You see that it is still executing. Now it has created an index. If I come on this website and if I refresh this page again, I should see index now. Now you see Llama integration example, and here also we have given the same name, Llama integration example. If I click on this and open, you will see some information, what metrics it is using to create index. So it is using cosine, dimension is 334 that we have defined here, and then this is the host name where it is hosted. Cloud is AWS, region is US East 1, and type it is serverless. Now if you see here, vector count it is 0. Right now it has just created an index name. Now we will create embeddings and then store it here in this vector database, and the count of this vector will change them. Let's go to the next step to see that. So first of all, we will initialize our index. We have already created this index. Now we have to initialize it. And for that, I will make one variable pinecone underscore index. And then I will call this PC. From this, I will call the method index. And inside this, I will pass our index name. So now this is our index name. That is why I am passing it here. Let us execute our code. So now we have initialized our index, and the next step is we have to create a vector store. So let's create a vector store. I will make a new object, vector underscore store, and then I will call this pinecone vector store that I imported here. Here you can see this one. So I will call this pinecone vector store. So it is used to interact with a pinecone index from within LlamaIndex. So whatever index we have created, this one Llama integration example, this class will help us to interact LlamaIndex with this pinecone index. Now inside this, the first parameter is, we are going to pass only one parameter, pinecone underscore index, and here we have to give our pinecone index that we have created here, this one. So I will pass this one here, pinecone index, and then let us execute our code. So this is done. We have created a vector store. Now we will initialize storage context. So what we have done so far here, we have created an index, we have initialized it. Now we have created a vector store. Now we will be initializing storage context. Storage context will help you to write your embeddings into this pinecone vector storage or vector database. Now first import this storage context library from LlamaIndex dot core import storage context, and now I'm going to make an object of this storage context. I will make a variable storage underscore context, and then I will call this storage context. Then from this I will call from underscore defaults, and then I will pass vector store. This is the parameter. Inside this I will pass vector store. So here we are passing this pinecone index in this vector store, and then we are passing this vector store as a storage context here. Now let us execute our code. So we have created our storage context, and now comes the last step where we will be creating an index, and that index will be stored in this pinecone, and then we will see the count of this will change from 0 to something. Let's do the last step now. We will be creating index. First I will import from LlamaIndex dot core import vector store index. We will be using this vector store index. I will make an object index and then I will call vector store index. From this I will call from documents, and then inside this I have to pass our document. So we have this document store in this object documents here, you can see. So I will pass this here, documents. The next parameter will be storage context, this storage context, and we have already created the storage context, so we will pass it here. And then our last parameter is going to be embedding model. So embed underscore model is equal to embed underscore model. Now what we are doing here in this index object, we are calling this vector store index class to create index. And what kind of index we are creating? We are creating an index of this document and using this embedding model, that is the Hugging Face embedding model, and this storage context help us to write this index in our Pinecone vector database. Now let us execute our code. It has created index, and if you see error like this, error display, then you don't have to worry about it, just ignore. And when you come on this page Pinecone, you will see that now the vector count is 21. It has created indexes and it has also stored here, saved it here, and you will see here index records. You will get all the informations or all the indexes starting from 1, 2, 3, 4, 6, 7 and so on up to 21. Now we can also query this data. For that we have to create a query engine. Let's do that. Set query engine. I will write here query underscore engine is equal to, then I will call this index that I just created here dot as query engine as underscore query engine, and inside this I will pass our LLM. So the LLM that we have created, LLM is equal to LLM. I'll make a variable response and then I will call query engine. From this I will call the method query. Inside this I will pass the question, what did the author do growing up? And then I will print this response, print response. I will get an error because I have to get this question mark inside the double quotes. Let us execute our code and let's see what response we get. This error I got because I have used incorrect LLM model. Let me go and change this. So here I will change this model. I'll write here Mistral 7 billion parameters instruct version 0.3, and this should work. I'll execute this code and then I will execute first this one and then this one. Now I should get the response here. Here in the output you can see I got the response. So this is the answer. The author worked on writing and programming outside of school. He wrote short stories which is described as awful. He also worked on the IBM 1401, an early version of Fortran machine, but he couldn't figure out what to do with it and so on. So I got the complete response here. I can even ask other question. I'll copy this and then I'll paste it here and I'll ask here what is the name of the author. So it should give me Paul Graham. Let's see what output I get. The author is Paul Graham. That's correct. So Here you have seen how you have to create an index and how you can store that index in Pinecone vector database, which is one of the most useful vector database that you can use for free. I hope you enjoyed this video. If you like my video, you can subscribe to my channel. Thank you for watching.